10.3 is all about operations with radical expressions. And there are 4 boxes to talk about, so let's get going here. First, we want to define what like radicals means. So here's an example of a like radical. This is radical 5, and this is 7 radical 5. The reason that these are like radicals is because they have the same index, which is the number that's sitting outside the radical, which in this case happens to be a 2, and they have the same radicand, okay? Rad 5 and rad 5 have the same index and the same radicand. So I can do operations with these as long as they have like radicals. Here is an example of unlike radicals, rad 5 and 7 rad 4. Now it is true they have the same radicand, the same index, but they do not have the same radicand. This is rad 5, this is a rad 4, therefore they are unlike radicals and we cannot do operations with them. So here are some quick examples of what you can do with operations. So if I have 6 rad 11 and 9 rad 11, I have a grand total of 15 rad 11 because 6 and 9 make 15. 1 rad 3 minus 5 rad 3 is a grand total of negative 4 radical 3 because 1 minus 5 is negative 4. Rad 3 and rad 3 are like radicals. 7 rad 2 minus 8 rad 2 is a negative rad 2. And similarly, 5 rad 5 plus 2 rad 5 is a 7 rad 5. So hopefully that's not anything that's too hard to see. The more important stuff or the more interesting things are when we start doing operations such as the following. If I do 5 rad 3 minus a rad 12, well, it doesn't seem like there are like radicals here, but indeed there are. So let me show you where it is and how to get it, okay? The answer is 3 rad 3, so how do we arrive there? Well, 5 rad 3 minus rad 12 can be broken up into a rad 4 rad 3. Remember, we know how to break up and simplify radicals. Radical 4, the square root of 4, is a perfect square, so that's 5 rad 3 minus 2 rad 3 give us a grand total of 3 rad 3. Similarly, check this example out. Let's say I've got 4 rad 7 plus 2 rad 28. You would think that there are no like radicals to be had, but indeed there are. 4 rad 7, good to go. 2 rad 28, here is where we find it. I can rewrite the square root of 28 as the square root of 7 multiplied by the square root of 4, and the square root of 4 can be broken down into 2, and 2 times the 2 outside gives me another 4 here. So 4 is the largest perfect square that is a factor of 28. That's why I chose to do it. So I've got 4 rad 7 and 4 rad 7 give me a collective of 8 rad 7. So hopefully this is making a little more sense. How about 5 rad 32 minus 4 rad 18? Let's check this one out, okay? The answer is 8 rad 2. How do we arrive at this answer? Okay, let's check it out and see. Well, again, radical 32 can be broken down into radical 16 and radical 2. 16 is the largest perfect square that's a factor of 32. So therefore, the square root of 16 is a 4. And there's my 5, rad 2 stays where it is. 18, square root of 18 is the square root of 9 times the square root of 2. Square root of 9 becomes a 3, and then rad 2 becomes a rad 2. This is a multiplication sign. So putting it all together, I've got 20 rad 2s minus 12 rad 2s gives me a collective total of 8 rad 2s. So those are some more interesting examples that we can do rather than just sort of the bare bones, okay? And here are some more interesting ones still. What if I have rad 10 times rad 6 plus a 3? Well, the answer for us is going to be 2 rad 15 plus 3 rad 10. Let's figure out how to arrive there. If I distribute rad 10 times rad 3, I get a rad 60. If I distribute rad 10 plus 3, I get 3 radical 10. 60 can be broken up into 4 and 15. 4 is the largest perfect square. That's a factor of the 60. That gives me a 2 rad 15. I can't do anything more with the radical 10, so therefore my answer is just 2 rad 15 plus 3 rad 10. This one's way more interesting though. Check this out. I am going to move this for a second over here. Then I'm going to grab this and show you how to do this one. This one's way more interesting, okay? Let's see how to arrive at the answer of negative 3 rad 2. Here's what you do. I set up a box method. I do 6 minus 2 rad 3 on the top and 6 plus radical 3 on the side. Rad 6 times rad 6 is a 6. Rad 6 times a 2 rad 3 is a negative 2 rad 18. That's a negative 2. Rad 6 times a rad 3 is a positive rad 18. Rad 3 times negative 2 rad 3. That's just going to be a negative 2 times a 3, which is a 6. And notice that the 6's cancel out. I wrote everything out here. 6 minus 2 rad 18 plus rad 18 minus a 6. That gives me a negative rad 18. I can break that down even further and get a negative 3 rad 2. That is a way more interesting example. Okay, box 4. Let's talk about something called the conjugate of an expression. If I give you the expression radical 7 plus radical 3, the conjugate of that expression is radical 7 minus radical 3. So what's changed? Obviously, the sign in the middle has gotten to be the opposite sign. Let's take this one, rad 2 plus rad 5. The conjugate is rad 2 minus rad 5. So again, the sign in the middle has just changed. If I have 3 minus rad 7, then the conjugate must be 3 plus rad 7. This is going to play an important role in just a second. So we can take an expression written in radical form and then find its conjugate by taking the opposite sign between them. This is going to be really important when we try and simplify this. We know we can't have a square root in the bottom, so what we do is we multiply by the conjugate of that denominator. And that denominator is rad 7 minus rad 2, so the conjugate is rad 7 plus radical 2. Rad 7 plus radical 2. Now here's what you get. 10 times the rad 7 is just 10 rad 7. Not much you can do there. 10 plus a rad 2 is just a 10 rad 2. The bottom is where it becomes interesting. Rad 7 times rad 7 is just the number 7. Rad 7 times a positive rad 2 and a rad 7 times a negative rad 2, those are going to cancel out, leaving me with a minus sign, and a rad 2 times rad 2 is just the number 2. So look what you have. You have 10 radical 7 plus 10 radical 2, all divided by the number 5. You would think we'd be done, but we can actually factor a 10 out of the top. And that will leave me with a radical 7 plus a radical 2, all divided by a 5. Now from here we can clearly see 5, or 10 divides 5 twice, so we end up with 2 times the parentheses radical 7 plus radical 2. And that's how we get the answer for that one. So again, the conjugate plays an important role in multiplying and simplifying radicals where their denominator has a radical. Okay, hopefully that makes some more sense to you. And we will practice a lot more in class.